Okay, you guys, this is the second video for the astronomy unit, and we're going to start with solar wind. There's a constant stream of electrically charged particles that are coming off of the sun's surface, and we know that the sun is made up of plasma, so that is the plasma that's kind of streaming off constantly. This comes from the corona, which is the outer atmospheric layer of the stars. And even though they move fast, they don't move the speed of light. They move about 1 million miles per hour. So remember, the light from the sun reaches us in about 8 minutes, but this is going to take a few days. The solar wind will take a few days to get to us. With an increase in solar activity, though, there's an increase in solar wind. So solar events like flares or prominences, CMEs, any of that stuff is going to create more solar wind. We do have an awesome characteristic. We have a magnetic field. Our north and south magnetic poles, it kind of behaves like a bar magnet with loopy invisible lines that extend from the north and the south magnetic poles. There's an awesome picture in your book. You need to check it out. There's also another image on the next slide that kind of shows that. Anyhow, the solar wind hits it, is deflected around it, but we are a little vulnerable at our polar regions because that's where the lines go in. So solar wind can get in there. And where at the poles it will interact with our upper atmospheric layer called the ionosphere. Ionosphere has the word ion in it, and so it's full of ions, charged particles. They're not excited, but when the solar wind comes across and interacts with them, it excites those atoms, and the electrons start skipping orbital paths, jumping up and down, and emitting light in response. That light, you guys, is called an aurora. And these are astounding. The aurora borealis is the northern lights, and the aurora australis is the southern lights. There's a pretty nice video right here that you can check out later. The risks for solar wind just constantly streaming across is that, especially if it comes in bursts, can disrupt radio and satellite communications. Your cell phones might go out, the reception might be not good, not really harmful to health at this point. Not common, but has happened before, are power grid disturbances. In Canada in 1989, there was actually a blackout that was strictly a result of solar activity, solar wind coming into our atmosphere and disrupting the power grid. Pretty crazy. There's a couple more videos there. Lots of images. You can see this is the sun, and an artist's rendition of the solar wind is represented by these blue lines streaming across space. This is a large space here, 1 AU. Anyway, it hits these yellow magnetic field lines, and it kind of repels around them. The loops bend over, and they flip over so they're not stuck there. But there's this entryway that they can get in, and so we have auroras that occur at the north and the south polar regions of Earth, and it smears it back too. So we have a very protected area. Our planet is very protected from the magnetic field. This is an image of the sun. The photosphere is blacked out with that disk. It's very bright, so we have to black it out so that we can see the two atmospheric layers, and so we can see the phenomenon that's occurring. This is a flare. This looks like a broken up prominence, actually, that's coming off. And strangely enough, we actually can see a comet moving through in the area on this image. It's kind of neat. Here's another image showing coronal openings where flare activity can happen. See a little bit of flare activity there, any of the bright spots. And these two images here are auroras, and if you see them here in Portage, which we can periodically see them in Portage, spaceweather.com is the website that shows you when auroras can be seen here. But we're going to have to look north, obviously, to the North Pole, so we're looking north direction, And here in Portage, it would not go as high as this image is showing. It's actually going to stay nice and tight to the horizon. So here in Portage, north of us is Kalamazoo. You almost have to get out of Portage in order to see them. Coronal mass ejections are the largest release of energy and mass coming off of the sun, and the next slide is going to show you a picture of that, but these are huge, CMEs. Your book doesn't have this in it, so you have to solely rely on the notes for that one. They are correlated to sun activity, but the cause is still a mystery. We haven't figured everything out with the sun. It's very dynamic and energetic and lots going on, but these are huge. They're not uncommon. They happen frequently throughout the year. They are associated with prominence, which is another vocabulary word coming up. They come from the corona, which is the outer atmospheric layer. They are massive, and so if their release is directed toward Earth, Earth can experience some issues. So we have radio communication disruption, just like we had with the regular solar wind. If you're an astronaut, you're out beyond some of the magnetic field lines, so you don't have as much protection from that. And solar wind is highly charged, there's a lot of radiation that comes off of that, so it's very dangerous as far as cancer goes. It can literally fry satellite electronics, and on a lighter side, it can cause beautiful auroras for us, but it's not unheard of to cause electrical power outages. Here's images. You can see there's a massive CME right here, which is bigger than the surface of the sun. Again, we had to block out the photosphere so that you could actually see what was going on in the atmosphere. This is a flare, a couple of flares you can see, so you can see the difference between a CME and a solar flare. The CMEs actually follow these loop lines. What do you think these might be? They actually are correlated with a strong magnetic field line, and you can see that they break up and all of that mass goes across space. Finally, the last definition for sun activity is solar prominence. And these are the little loopies. They look a lot like CMEs, but they're much, much, much smaller. And we have them coming out of the inner atmospheric layer called the chromosphere, and they extend out into the corona, but they don't extend any further than that. They can break apart, like you see here, and unfortunately the video is cut off. So Earth is about, if you look at my little circle I'm making with the cursor, it's about this big. Just give you perspective.